Hello, welcome to College Algebra section 3.5. My name is Rob Reynolds. Today we're going to be looking at graphs and their transformations. When I talk about transformations, I'm talking about a horizontal shift, and horizontally we're going to shift left or right. I'm going to talk about a vertical shift. Vertically we're going to shove the functions up and down, and then there's a vertical stretch. So don't get the vertical shift and the vertical stretch mixed up. The stretch is kind of like a rubber band, and if I pull on that rubber band, it's going to make it either more narrow or make it a little bit wider. So we'll check that out. Vertical, horizontal, and vertical is where we're going to start with. So this is a vertical shift. It's going to take this parabola, which you know starts at 0, 0, and this is a vertical shift of 3 units up. So it's going to physically just move. And remember, it's always over 1 up 1. So to find this next point, I go over 1 and up 1. As long as that coefficient is a 1, which that's the stretch, but we'll talk about in a moment. But for all functions, it's always over 1 up 1. So I'll give you a general equation here. Y is equal to a, x minus h quantity squared plus k. And if you're taking notes, if it says plus k, we're going to move up. That's what we just looked at. If it says minus k, we're going to move down, just like you think it's going to do. If it says, though, minus h, it's going to go the opposite of what you think. Minus h does not go left. Minus h actually goes to the right, and I'll explain that in just a moment. Plus h goes to the left, and then this forms my vertical stretch. It's going to either stretch or shrink. If a is a number, it's going to stretch. If a is a fraction, it'll shrink. So vertical stretch. So let me go back to this part and tell you why this is going the opposite direction. It's called the root, and if I have x minus 3 quantity squared, if I set that equal to 0, I really want to know when does x minus 3 equal 0, and that happens when x equals 3. And notice that that 3 is positive, which means I'm going to move to the right. So whenever you see parentheses, the rule is go the opposite direction. If it says x minus 3, this actually goes 3 units to the right. So looking at, there's the author's answer, 3 units up. This one's going to go 2 units up. This one's going to go 2 units down. So I'll graph the original. This next one goes 2 units up. So it looks like this in yellow. And then this blue one is going to move 2 units down. So I go back to the original and move 2 units down. So again, they all look very similar. You can take your graphing calculator and explore with these. This one, 4 units down, it says. So I start here and draw the parabola in. This one is your first horizontal shift. Remember, this goes the opposite direction, so it's actually going 2 units to right. So instead of starting here and drawing the parabola, I'm actually going to start at 2, 0. And then, remember, since this is a 1, it's going to go over 1 up 1 in both directions. It's always over 1 up 1. If you want to find additional points, plug in for x and solve for y. This one's going to go to the right 3, and this one's going to go left 2. So again, the original function here is in purple. If I move that, well, it's kind of neat. I could probably just move it right here. That purple function is going to move 3 units to the right. So there is the y sub 2. And 2 units to the left, there is y sub 3. So it's kind of neat that I can just move this along. And there they are, all in the same graph, which is kind of confusing to look at. I think I was giving my class a choice of which graphs. I think I like this graph better over here, although it's not a 10 by 10 by 10 graph. This says 4 units to the left and over 1 up 1. And there's the final solution. This one is your first one that you can see. This goes 3 units to the left and 5 units down. So if I start here, go 3 left and 5 down, there's my new start value right here. And then since that's a 1, I'm going to go over 1 up 1 in both directions. I know from my Simon Says game that this is a y equals x squared, so I'm going to graph that parabola. The book is going to go through step by step, but they have the exact same answer that we did eventually. Compressions or stretches, this is the value of a that they're talking about. So we know that h is moving left and right, the k is moving vertical, and now we're going to look at the compressions or stretches. So this is going to have a vertical stretch of 2. It's a V for victory, beat valley. So the original function looks like this, over 1, up 1. But this actually now says don't go over 1, up 1. This 2 says go over 1, and it's always, here it comes, always over 1. And then it's up your A distance. It's always over 1 though. So I'm going to go over 1, but I'm not going to go up 1 this time. This time I'm going to say, let's go over 1. This says, I'll do it in purple, over 1, up 2. And you can see that's vertically stretching, making it more narrows, and I like that. The numbers make it narrow, and if I have a fraction, you guessed it, that will make it fat or wider. But I like the ends to go together for narrow, and here it is, a great example where it's a fraction where I'm going to go over 1 only up a half the distance, and that makes it a little bit wider. So I think what this is all about is let's figure out what's going on underneath this beach ball here. If I were to replace f with, replace x with 4x instead of f of x squared, I'll have something squared. So I'm replacing that x value with whatever it tells me, and this time the x value is 4x. So this is actually 8x squared. So you can see that that's going to be very narrow. It's going to start at 0, 0, but go over 1, up 8, and I'm off my graph. So it's a very narrow, well, I kind of missed over 1, so up 8, over 1, up 8. And that's what's under this first beach ball. The second beach ball is a half, so it would say replace x with a 1/2, square it, so it's only a 1/4. But still a parabola, and you can graph it, but it's going to be very, very narrow, and you can see that it's a very fat graph on your graphing calculator. This is kind of interesting. It's asking you to look at, we're not going to do trig, but it says look at this sine wave function, and we're actually going to shove it, no, we're not going to shove it left or right or up or down. This 2 is a vertical stretch, so instead of going up 1 unit and down 1 unit, we're going to stretch this thing up and stretch it down. So our full cycle, it will look the same, still between 0 and 2 pi, but it's in red. This guy is actually a period change, and I'm not going to mess with him. Some of you know this 2 pi divided by b business. This is actually going to cause it to be 3, where there was 1 between 0 and 2 pi. So let's see, if I draw the sine wave between 0 and 2 pi, where there was 1, this now says there's going to be 3 of them. And I don't think I want to, let's see, 1, 2, 3. I can't draw it, and I'm not going to, oh, there's a better graph for it. There's the final solution. There it is. There's 1 of them, there comes 2 of them, and then 3. Well, no, I actually should have had all 3 of them between. There's 1. Yep, that's 1 of them. The second one is here, and then the third one is here. So what this says is where there was 1 between 0 and 2 pi, now I've got 3 of those between 0 and 2 pi. I think I'm not going to test over that. Graph the function, but it might be your homework. So looking at reflections about the x-axis or the y-axis, this is similar to even and odd functions. For even functions, if you replace x with negative x, you get the same function, it's even. If you replace x with negative x, you get the opposite function, then it's odd. This is similar. This says I'm going to go down instead of going up. So instead of y equals x squared, instead of facing up, I'll have y equals negative x squared, and that faces down. And notice that that's reflecting about the x-axis. I'll draw in that line there. So you can see if I were to fold the function or the graph over the yellow line, the blue would fall on top of the green. But you can see that I'm going over 1, up 1 here, and then this point would be go over 1, down 1. So what's happening? I'm replacing the y with what? Negative y, and that's what this says. If y is equal to, remember, f of x is equal to y. So this says if you replace y with a negative y, then it reflects about the x-axis. So here comes the rule. If you replace y with negative y, it reflects about the x-axis. Guess what? If you replace x with negative x, then it's going to reflect about what? Yep, you guessed it. It's y. It's opposite of what you think. So I would have that in my notes. So there's the function we just talked about. Hey, what happens if you replace x, because the original function is the square root of x. So this is what the square root function looks like. What happens if you replace x with negative x? Well, we just said, if you replace x with negative x, that reflects about the y-axis. So instead of heading off to the right, this is going to reflect about the y-axis, and it's going to head off this direction. So I'll draw that in. And if you wanted to find points over 4 up 2, I missed a little bit. So remember, you can take the square root of, let's try a negative 4. If you let x equal negative 4, then my function is the square root of the opposite of negative 4. So remember, these values, this x has to be good for negative numbers, because this is now saying what's the square root of 4, which we know is 2. So that's why I would plot the point negative 4, 2. And that's why it's heading off to the left, where all the negatives are, because this is now pronounced the opposite. And the opposite of this negative x is a function. That's what the book uses for their stretches. If the value of a is greater, it's going to go up. If the value of a is less than, it moves down. Horizontal shifts, shrinks, you can read through these. This is a busy slide, but it's kind of a good information here. It says if you start with, let's see, this is the blue function, the original y equals, it's a V for victory, I think that's in blue. So if you shove this 2 units left, I believe we're going to get the pink function. And then if you go 3 units up, we get the green function. And then if you reflect, it'll move green to the red function. So I hope you can see all that. So I want you to talk through, if we take this original function, y equals the absolute value of x, and if we actually shift it 2 units to the left, is that going to be plus 2 or minus 2? And is that inside the absolute value or outside the absolute value? Well, it's a horizontal shift, 2 units to the left, so it's inside, but it's going to go the opposite. So I'm going to say x plus 2. That's the, oh yeah, every time I see parentheses, go the opposite direction. And you're going to say, well, I don't see parentheses, but it's actually there. To type this in the calculator, you would have to put parentheses around that x plus 2. Then to go 3 units up, that's the k shift. That's going to say plus 3, and then you would tag that on to the end, adding 3. The last one is this reflection. I remember, if it reflects about the x-axis, which it does, because you're moving this green to the red, it's reflecting about the, that's not the x-axis, excuse me, I misspoke. That's the y-axis. So if I reflect about the y, I have to replace x with negative x in order to reflect about y. So that's what it says, replace x with negative x, because I'm reflecting about y, and then the new function would look like the same as the old one, just replacing x with negative x. So that's how it's going to kind of show you on My Math Lab to walk through these things. This is going to have a horizontal shift. What causes the horizontal shift? This down below. This is going to go 2 units to the 2 units, and it's going to go to the right because it's going to go opposite of what you think. 2 units to the right. This is going to have a vertical shift of what? Well, it's vertically shifting, looks like up 1 unit. So I would say it's vertically shifting 1, and it's going up 1 unit. And the vertical stretch is 3. That comes from the numerator because it's out front. And then you could graph that. Remember, this is that John Travolta thing. So I'm taking this function, which is the 1 over x, and I'm doing all of these transformations to it. And so your final graph would be this in step 4. It's getting shoved where? 2 units to the right, 1 unit up. So my axis goes 2 units to the right and 1 unit up as well. So the horizontal is here. So the vertical axis, so there's kind of the center. And then from there, I would, instead of going over 1 up 1, I'd go over 1 up 3. And so you can start seeing, if you know the general functions, over 1 down 3. Start seeing these functions. That's your vertical stretch. Well, that's the same thing that they have here, over 1 up 3. So that point is 3, 4, and I think we had a 3, 4, 2, right? 3, 1, 2, 3, boom. there it is, 3 comma 4. So I would just graph the final solution. I wouldn't go through and graph each piece individually. This is kind of tricky. We'll let this one hopefully be the last one because I'm going a little bit long. This has reflection because I'm replacing x with a negative x. That means I reflect about the y. But what I wanted to talk to you about is, does this move 1 unit to the left or 1 unit to the right? So let's set 1 minus x equal to 0 and find out. So negative x is negative 1, so x equals 1. So that goes 1 unit to the right. This says 2 units up. So I'm going to start here, go 1 unit to the right and 2 up. And if you know the square root function, I go over 1 up 1. But wait a minute, we forgot about the reflection. The reflection says if I replace x with negative x, which I have, then it reflects about the y-axis. So instead of heading off to the right, I really should be heading off to the left. So it's over 1 up 1. Why is it up 1? Because the value of a is 1, and it heads this direction. So it looks like this point's going to be a 3 comma 0. And yep, there's the final. The author agrees with me on that. And then we had some multiple choice questions for you to choose, but I'm running a little bit long. So I hope that's helpful. Email me with questions. Thanks.